please, everyone, put your hands together. Give a very warm welcome to Evan Cummack.
Thank you. Thank you. It shouldn't be where we are. It shouldn't be where we are at all. This screen is good, and this screen up here is very far forward in the presentation, is all I would say. I'll let these guys figure this out. Good afternoon, everyone. My name is Evan, and as mentioned, I'm the head of IoT and wireless research and development at a company called Twilio. Twilio, who out of interest has heard of Twilio, just from my knowledge? So probably slightly less than half, actually, which is interesting. So Twilio is a API-driven developer platform for communications. We have about 5 million developers in our ecosystem, and they use our APIs to build all sorts of multimodal communications experiences. We're a publicly traded company, about 10 years old, founded in San Francisco, but we have offices all over the world, including an office which is focused on IoT R&D right here in Potsdamer Platz in Berlin. And as I mentioned, we are really obsessed with developers. And today, what I want to talk about is an opportunity that we perceive, which is this massive economic transformation that we believe will be led by developers, and it will be focused on IoT in the real world. Is this working? It is working. So my goal today is I want to convince you of three things. I want to convince you that there is an IoT explosion going on, and it's maybe not the one that you're super familiar with that we hear about in the mainstream tech press all the time. I want to convince you that this opportunity creates a tremendous amount, an almost unprecedented amount of entrepreneurial white space, and that there's a reason to care about this right now. And the reason to care about this right now is that it is being driven by a perfect storm of component technologies in both the economy and the technological ecosystem. But it wouldn't be an IoT talk if we didn't start with a little bit of hype. And the IoT ecosystem is really, really growing extremely quickly. Last year, in Q4, there was about 15 billion euro of venture capital that was invested in Internet of Things startups. That's a 94% year-over-year growth. There are, by some measures, about 20 billion devices, IoT devices, connected to the internet today, which is quite absurd. And that rate is actually growing very quickly. It's growing at a rate of about 127 devices per second. So that means that probably, and of course this doesn't all happen in a continuous time frame, but there could be about 10,000 devices that have come online for the first time since I took the stage and started talking to you all today. It's pretty mind-blowing. But when most of us think of IoT, and we're sort of primed for this from the media and from advertising, we think of devices like this. We think of the devices that sit inside our homes. And this is very valid. Actually, for now and for the next few years, about 60% of all IoT devices or IoT-like devices will be consumer electronics devices. But I want to talk a little bit about that ecosystem, about the smart home economic and innovation system. So the thing that stands out to me the most about it is that it's dominated in large part by the usual suspects, by the FANG-type companies, the tech titans. You have Amazon, who acquired Ring. You have Google, who acquired Nest. You have Samsung, who acquired SmartThings. These companies all have a smart speaker product, which they're trying to make the centerpiece of the home. They all have a smart TV product. These are the same companies that 30 years ago battled for space on our desks. 15 years ago, they battled for space in our pockets, and now they're battling to control the place where we live. And the smartphone war, admittedly, I think, has been won, and we'll talk a little bit about that as we go on. But the smart home war is in full swing. And it's quite easy for me to reason about why this is happening. This is a huge market, very international, relatively homogeneous set of requirements. I think that it's reasonable to say that the economics here will look like winner-take-most economics. And those are the types of economics that we're used to from the software world. And so it's understandable then that a company like Amazon would use the most precious space that they have on their homepage to advertise not just in Germany, but also in Japan, in Mexico, and in the United States to try and really push their range of home products. And I have no problem with this whatsoever. I think it's great. I think it potentially will open up a lot of innovation, and there probably is a lot of entrepreneurial opportunity here. But to me, there's another IoT explosion going on, and it's a lot more interesting from an entrepreneurial perspective. So let's talk about it a little bit and what it means. We're talking about the IoT that's happening outside of the home. And it's happening on a very different set of networks. It's not happening on your home Wi-Fi network. It's happening primarily on the cellular networks around the world. A little tiny bit is happening in satellite, but for the most part, this is happening on cellular networks. And to explain why I think this is so important to developers, or so interesting to developers, I want to take a look at two of the fastest growing companies in recent history. And in fact, these are two of the fastest growing companies in all of history. They're at very different stages in their life cycle. So one is Uber, and one is Lime. And if you live here in Berlin, you may have noticed in the last few weeks a lot of these scooters showing up everywhere, which is an interesting phenomenon to say the least. You might say, look, this is, one of these is a ride-sharing company, one of these is a micro-mobility company. In my mind, these are IoT companies, true IoT companies in the truest possible sense. And the reason is that what they do is they take physical resources from the outside world that weren't normally considered computing surface area, and they bring that in, and they make that into an interactive participant in a digital system. So both companies do that in a very different way. Uber does that with a smartphone and a human operator, and Lime actually does that with an integrated IoT module, which is something that's becoming a lot simpler, which we'll talk about in a little bit. But my point is the same, is that they are bringing the world into the internet. You can understand when you look at one of these maps, the location, the utilization, the capacity, the availability of some resource that previously was an offline resource, that previously was just a dumb resource, if you will, and they've made it smart. These are real-world objects that are participating interactively in a digital system. And so I would summarize that by saying, by understanding the real-time state of the world, IoT enables physical objects to become actors in interactive software systems. And that really is all that IoT is to me. But that's not a super revolutionary idea. One thing that is really interesting to think about is this notion that IoT is not actually about the hardware. All that the hardware does, all that the hardware is there for, is so that we can put software where there was no software before. And that's a really, really interesting concept from a disruption perspective. So the reason that I really wanted to use Uber as an example is not because I think they're the best, most quintessential example of an IoT company, but they are a really good example of how things used to work before they were part of a software system. So for many, many years, almost 100 years, or more, actually, if you consider other modalities as well. This was the best system that we could come up with for sharing these transportation resources, essentially. It was cars just drive around and around and around and around and around, and then you go and stand outside, you put your hand up, and you hope at some point that there's a collision, and that collision solves a problem for the driver and solves a problem for you. This is what I would describe as a brute force system. It's a brute force approach to the physical economy. And brute forces represent inefficiency. And what they actually represent is an information gap, like I just mentioned. And when you start to look at the world through that lens, what you notice is there's tons of these information gaps everywhere. And it's these information gaps, I would proclaim, is what creates the entrepreneurial white space. So let's go back a little bit in time to, say, the dot-com boom, when the internet of information, if we want to come up with a contrasting term, began. And it was such a powerful force that it really created all of this entrepreneurial white space for entrepreneurs. You could look at almost any business, and lots of people did. They looked at all these businesses and said, we'll put it online. It's like, what's E-Trade? It's a bank, but it's online. Like, what's Esurance? It's an insurance company, but it's online. And that one thing, that one change in the competitive parameters for products was enough that these companies were actually able to go and disrupt companies that had existed on traditional competitive parameters for that ecosystem for hundreds of years. And of course, many of these companies failed, but some succeeded. You could think of an example. I know of one person who apparently took a bookstore and put it online. And I heard that this person was tremendously successful. And the Internet of Things represents in some ways the same opportunity, but not for the information processes of our life, like banking and shopping, but for the physical processes that are around us every single day. And I have some other examples that I think are a little easier to reason about. They're smaller, and it shows like how powerful as a small startup you can be when you harness this concept and go and compete against entrenched companies. So there's this company, Sensenio. They're based in Slovakia, a small startup that decided to solve an inefficiency in the waste collection space. So waste collection, the way it used to work is very similar to the taxi. A bunch of truck drivers would wake up in the morning, get in their garbage trucks, drive the same route. This bin gets emptied every Wednesday. This bin gets emptied every Friday. And what Sensenio did is they put these cellular connected, narrowband connected actually sensors into these trash cans. But they didn't just stop there and say, hey, here's a connected trash can, you can have it, to some enterprise. What they did is they built an integrated software system where the trash cans were now a part of that system. It was a player in the system. And so what happens is every single day, truck driver wakes up, goes and gets in the truck, and using some basic machine learning algorithms, all of the routes for every truck are determined dynamically every day in order to make sure that the most efficient collection of that waste occurs. And what they found is that cities that have adopted the system have cut their costs by about 30% and actually cut their carbon emissions by about 60%, which is really interesting because if you think about it, that waste, that carbon emission, obviously very wasteful environmentally, but also just it's a proxy, it's just a representation of something that was being done before that did not actually need to be done with the purposes of solving this problem in the economy. Another nice little example, a company called Pulsar Sensors. This is a small startup out of San Francisco doing something very similar in the gas industry. So there's gas that gets used all over the place. It gets used in dentists, it gets used in restaurants, and all these types of places. And they built this very simple sensor, again connected with a low-power cellular network, and they sell it to gas distributors. But they don't just give you the device. They've built a system, they've built an intelligent software system that tells the gas distributor, hey, this is where you should be going today, this is your highest priorities, et cetera, using machine learning, and it's based on basically their predictive analytics of where they should be. And what they found is, again, a 40% decrease in the amount of wasted time that folks are spending truck rolling, which essentially represents that before this type of system, 40% of all the work they were doing was a complete waste of time that was just based on brute force and based on a lack of truth or a lack of knowledge in the overall system. Okay, so here's where we are today. There's about 1 billion of these devices being shipped this year, which is actually quite a lot. But within about 4 years, that's expected to be about 3 billion devices. So this is a huge opportunity. But one of the things I want to emphasize is most of these really great mega trend opportunities, like the web or like mobile, they have some reason that they happen at a certain time. And you don't necessarily want to get on this wave too early, or else you're the person who spent all of their time learning how to develop apps for the Nokia N95, right? You started a little bit too early. But you also don't want to get in too late, because then you miss out on all of the great, juicy, frothy opportunities that exist in a new ecosystem. So if we look at what's actually involved in a standard cellular IoT device, outdoor IoT device, you see a bunch of things that are probably familiar. Sensors, microcontrollers, GPS, LTE modems, lithium-ion batteries. And while this stuff all would have been possible, say 10, 15 years ago, it would have been extremely expensive. And in some cases, it would have just been completely unrealistic. You wouldn't have been able to justify a lot of these use cases. You might have been able to justify something in the military space, but maybe not justify something like sharing a scooter. And so what I want to emphasize is that there's this perfect storm of components and economic trends that are going on that make this a really interesting ecosystem to dive into right now. There's this concept called peace dividends. And I'm not sure if any of you have heard of peace dividends. It's actually coined at the end of the Cold War. And what it was related to is this notion that There's economic benefits that come at peacetime, at the end of the war, when you take all of your military production and you turn it into civilian production, essentially. And there's a really smart guy called Chris Anderson who runs the TED conferences, and he coined this term, the peace dividends of the smartphone war. And we mentioned earlier that the smartphone war is sort of over. The winners are relatively declared. That industry is actually growing relatively slowly. But all of that stuff that Google and Samsung and Apple invested in so heavily to win that war is now extremely available and extremely inexpensive. So things like the GPS, like the camera, ARM chips, processors, all of this stuff was really difficult before and now really, really easy. And in my mind, there's sort of three dimensions upon which it's really useful and what makes it a really awesome time to be an IoT developer right now, which is the smartphone war gave us incredibly inexpensive and readily available hardware. It built out the networks to beyond anything we could have imagined a little bit earlier, and it created this everywhere user interface. We'll talk a little bit about this, but this is really important for, say, like a product like the scooter sharing. It's like no one wants to run back in their office and sit at the PC and book a scooter. So by having that always-on user interface, you actually open up the IoT itself to new use cases. So really quickly, and I don't think I need to explain these too much, but about an order of magnitude cheaper now than it was 10 years ago to get a lithium-ion battery. Huge growth in mobile data. What this has done, weirdly, this huge growth in mobile data, is it's forced governments to rethink how they allocate spectrum. So for example, in the United States, you have them reallocating television spectrum to cellular to support this type of thing, but then inadvertently, we benefit when we're trying to deploy IoT devices because we have more capacity, better speeds, lower costs, all that kind of stuff. And density. In the 5G requirements, call for about 1 million devices per kilometer squared. And to give you a context of what that means about 1 billion devices connected to a single operator network on a city about the size of Berlin. I talked about the user growth, and we're at a point now where within a developed economy, you can fairly reliably assume that one of your target users is going to have some sort of user interface that they can use wherever they are to interact with your IoT device, which is a big game changer. And so collectively, again, these things are just a perfect storm. This is the right time to try and go and build something here. It's not too early, it's not impossible, but it's also not too late. There's so much opportunity that is untapped with these, like I say, these brute force processes and these things that are just uninformed right now that can be economically transformed through the IoT. So I just want to summarize really quickly. Today we talked about the idea that there is this other IoT explosion, the IoT explosion outside the home, that it is creating entrepreneurial white space, and that now is the time to go and do it. Softwareization of the physical world will equal disruption of the physical economy. So I would encourage you to identify an inefficiency in the physical world, a process built on a schedule, or one that relies on guesswork or the provisioning of excess capacity. A really simple example, like maybe your office reliably orders too many coffee beans and they go bad because you never want to run out. You can imagine a connected version of that system, and if you really look into it, I think you'll discover an opportunity to improve the economic and the environmental efficiency, and in doing so, you will literally change the world. So as we like to say at Twilio, we can't wait to see what you build.
Amazing. Thank you so much, Evan. We do have some time for some questions, so let's pull up the Slido. What do we got? I have a question.
Sure.
So as we move towards a more like contextualized world, are there ways, like, obviously building systems for different cultures or different environments or locations at scale is difficult. And so what are some of the challenges, or I guess more importantly, what are some of the things that you're really excited to see this IoT kind of space move towards?
I'm actually most excited. It's really hard to evaluate what the impact of this will be on energy. But it does seem very obvious on the surface that a lot of energy resources in particular are consumed for the sake of not knowing how to do it any better. right? So a really simple example is just like in trucking. It's how many trucks are driving around half empty. Like that problem is already sort of being solved by a lot of companies, but you can really take that to the extreme. So you can say, okay, I have a network of streetlights, and those streetlights are actually sharing data with buildings around them to prevent the buildings from like overcooling themselves and then having to overheat themselves afterwards and stuff like that. Like it just seems like having a lot of knowledge of the physical world is actually going to prevent a lot of wasted energy. But it's actually very hard to tell. I've tried to do a lot of research into this. It's not clear what of all of the world's energy consumption is could be considered wasted or non-essential, actually.
Okay. Well, hopefully that problem gets solved soon. So everyone, give it up for Evan.